This lesson is about drawing trigonometric graphs, specifically sine and cosine graphs. Okay. Quick reminder of what these graphs look like. So a sine graph starts at 0 because sine of 0 is 0, and it has a period of 2 pi because that's how long it takes for the cycle to repeat. Cosine starts at 1, okay, and has a similar thing happening. Okay, so I normally just remember sine O, that's all I need. Okay, sine starts at 0, and it also tells me sine is opposite over hypotenuse, if I was doing any trig. So what we're going to be able to do is draw these sorts of functions with any transformations that may occur. Okay, so our general form is y equals a sine bx plus c plus d, okay, where a, b, c, and d are constants. So this original sine graph is really 1 sine 1x plus 0 plus 0. Okay. And then what we'll do is potentially change A, change B, change C, change D, and see what happens. So you can have a look at this applet and play with it if you want. This is our basic sine graph. If I change the A value to make it, say, positive 2, you can see that the amplitude goes up to 2. So the distance between the average value and the maximum value is the amplitude. I'll put it back to what it is at 1. If I have it as a negative value, okay, difference is that graph goes down instead, okay, instead of up. So that point that was up here is reflected underneath. Okay, we can do similar things. We'll choose D first. Okay, what D does is shift it up or down. So if I have a D value of, say, 2, instead of the function going through the x-axis, it will go through this line x equals 2, okay, as the average value. Okay, and then I could also have an amplitude of 2 here, okay, and we can see average value of 2. So add the amplitude to get the maximum, subtract the amplitude to get the minimum. Okay, so I'll go back to our base function. Oops. Yeah, there we go, base function. And we can have a look at what B and C does. If I increase B, it makes the period shorter. Okay, so where originally my period was about 6, okay, it's actually 6.2 or 2 pi. If I change this to 2, my period is now, that's 3.14, okay, pi. If I make it less than 0, like a half, I can see my period is now 12.46. Okay, it'd be 4 pi period. Okay, so if B is greater than 1, it gets faster. If it's less than 1, it gets slower. And the C value is responsible for shifting it left and right. Okay, so this is all just review. So in these notes it says A is the amplitude. So on this diagram we can show an amplitude. D is the vertical translation. Okay, so whatever this average value is D. And then we've got horizontal translation of C divided by 2, C divided by B. Okay, so a combination of what the period is and what the translation is, okay, combining those two. And our period is 2 pi on B. Alright, so it's more, and just remember the period is like this distance, okay, period. So it should actually draw one of these. It states this, tells us the domain over which we're drawing it. And it tells us to state the transformations as well, so we've got to make sure that we do that. So I'd start by just identifying that a equals 3, okay, which is going to imply, I got the a from there by the way, comparing it to the basic form. A equals 3, b equals 2, d equals -1. Okay, so a equals 3 implies the amplitude is now 3. B equals 2 implies the period is 2 pi on b, also known as 2 pi on 2. And the period is just going to be pi radians. And d equals -1 means that the average value will be -1. So, as a rough sketch, okay, I know that it's going to be passing through -1 on average. Okay, so I can put a little dotted line through here. Okay, it has an amplitude of 3. So from -1, we're going to go up 3. Okay, so up 1, 2, 3. And I'll get to 2 here as my maximum. And I'm going to go down 3 as well. And that'll be my minimum point. Okay, so, and remember my period is pi radians. Okay, I'll always divide these into 4 sections. So, it's a cosine graph, so it'll start at the maximum value, go down, go to the minimum value, go up, and up to the maximum. Okay, and because I know the period is pi, I know this distance needs to be pi. So this is pi on 2, this is half of that, pi on 4. And this will be between the two, 3 pi on 4. Okay, that's probably the easiest way to draw this graph, I'd say. Okay, so you can sketch it in that way if you want, if you're comfortable doing that. An alternative way is to do it in 2 steps. Okay, where we take care of any of the amplitude and period first, and then deal with the vertical translation. Okay, so remember the D value was a vertical translation. Okay, so the alternative method would be just looking at this one, I forgot my domain was from -2 pi to 2 pi. Okay, so you'd need to go out to 2 pi and go back out to -2 pi and can continue the pattern in both ways. Okay, you'd obviously need to show that. Yeah, the alternative method is to draw up my set of axes. Okay, since I know I'm going to do this properly, okay, I know that I need to go from minus pi to 2 pi, so I'll draw these on. Okay, and all I'm going to draw at the moment is the amplitude and the period. So I know at 0 here, I'm going to have to go up 3 and down 3. Yep, so I've got my amplitude ready to go, and my period is pi. So I'll draw my period in as well. Yeah, so some people prefer this method where we draw in the base line in black. Okay, and follow it through for all these ones as well. And we'll do the same in the negative axis. Okay, and then from there, so I've done these two. From there I can, done these two. I wanted that in black, but that's right. And now I'll do the vertical translation of -1. Okay, so I'm just literally grabbing all these points and moving them down one point. Okay, hopefully you can do it with a bit more detail than me. Okay, and then we'll just connect the dots as per usual. Okay, some people prefer this way for when there's both vertical and horizontal translation. Okay, but it's up to you. Whichever one works best for you. Okay, hopefully we're reasonably comfortable at drawing these from last year in any case. Okay, make sure you actually get it through the lines. Okay, so you got either option, okay, but it should look like the green one. We should have our axes marked, x and y, and we should have the final function drawn on the graph. Okay, how can you check that your answer's right? Put it in your calculator, okay, or you can just choose any of these points. Okay, obviously you need to label all these points, but just choose one of these points, say 3.2 and -4, okay, and you can sub it into there to check that it works as a spot check during the exam. Yeah, good communication justification too, to check things like that. Okay, one more graph. Okay, I'll just do it in the simplified form. So I've got a equals 5, so my amplitude is 5. I have b equals 1, so my period is 2 pi on b, or 2 pi on 1. My period's 2 pi. I have c equals pi on 4. Okay, so this is a horizontal translation, okay, of pi on 4 radians. And d equals 5, okay, vertical translation. Okay, remember with the horizontal translation, it's opposite to what you normally think. So this plus here would mean to the left, okay, making it happen earlier than it would previously. Alright, so where am I sketching this? Let's just assume it's from, it's my period 2 pi. Why not just from -2 pi to 2 pi? Okay, so I'll draw up my axes. And my amplitude is 5, okay, my base function, so I imagine it going between 5 and -5. Okay, but I have a vertical translation of 5 as well. Okay, so it's not going to be between -5 and 5 at all. Okay, it's going to be between 0 and 10. Okay, my average value of 5, and everything's going to happen between 0 and 10. My period is 2 pi. Okay, so I'm imagining up to 2 pi, all my sine stuff's going to happen. Okay, so I'm imagining at the moment something like this. And unfortunately, this phase shift of pi on 4 is going to be a little bit frustrating. Okay, so the way it's going to work is that all of these points are going to be shifted pi on 4 units to the left. Okay, so this is only, we've only looked at the amplitude and the vertical translation. Okay. What our graph's going to look like is there's going to be a point starting at minus pi on 4, which would be the maximum point. Okay, at positive pi on 4, we'll have, correction, at minus pi on 4, it'll be, here's 5, here's 10, here's 0. Minus pi on 4 will be that starting point. At pi on 4 will be the maximum. Okay, and then we'll have to shift all of these points pi on 4 as we go. So okay, at pi on 2. Okay, so it's probably good to label all of these. Okay, the distance between all the points is pi on 2. Okay, between those 4 significant points. Okay, so my next point on this side, okay, will be pi on 4 plus pi on 2. Okay, to get to that average value. Okay, and then I'll have to add another pi on 2 to get the next one and the next one. Okay, alternatively, probably easier would be just to subtract pi on 4 from each of these. Okay, so I've done it for here. Pi minus pi on 4, 3 pi on 4. Okay, 3 pi on 2 minus pi on 4. Okay, would be, so you're going to make common denominator, 6 pi on 4 minus pi on 4. Okay, you got 5 pi on 4. And then this final one, okay, 2 pi minus pi on 4 would be 7 pi on 4. Okay, so we'll be graphing like this. Okay, to get our proper function. Okay, this would be, and then make sure I write the equation. 5 sine x plus pi on 4 plus 5. Okay, so it takes a little bit getting used to, you need to figure out your own system. Okay, and obviously you can always check your solutions by subbing in a point. Okay, these are the exercises you need to have a go at. Yep, good luck.